Hello, how's everybody doing? I decided to put some more examples in this video of how we use the definition of the derivative. So let me show you uh, two additional examples. So to find the derivative, you have to find the derivative of f of x equals 1 over x. Alright, we would like to find the derivative of this using the definition. Here's the solution. Okay, to do this, well, first step is always put the definition of what the derivative is. Alright, now all we do is have to fill in the blanks. Remember that f of x plus h is equal to 1 over x plus h. And the reason that I'm doing this is that every instance that we see the value x, we have to substitute it for whatever we have inside this parentheses. So in that case, in this case we have x plus h. So we just substitute the x by the x plus h. Next step is, well, we know what f of x is. This is equal to 1 over x. Right? Now I'm gonna plug this guys, I'm gonna plug it in here. This guy, I'm gonna plug it in there. All right. So continuing on in that definition, I'm gonna rewrite the definition here. Hope you remember what the values of um, f of x plus h and f of x are. So upon doing this substitution, this is the limit as h approaches 0 of 1 over x plus h minus 1 over x, all that divided by h. Now, the only challenge here is that we have to do some additional algebra. So I need a little bit more space here. And I'm going to write that down. I'm going to break this. I'm going to put this fraction in another way because these things are equivalent. Alright. Now, the next step here is that we have to combine these two fractions. So combine. Right? By combining, I mean, of course, using algebra. We're subtracting this. So you have to find the greatest common factor, the greatest the greatest common factor to get the least common denominator. So what we get here then is x over x, x plus h minus x plus h, x and x plus h. Right? Now in the limit as h approaches 0, I'm going to combine these fractions because now they have a common denominator, and this is what we get. Notice here we're subtracting, so since you're subtracting, you have to distribute this negative sign to both x and h. Remember, the reason we're doing this is because we're subtracting. if you remember the previous expression, then we write this as the limit as h approaches 0 of x over x plus h x plus h. Remember, what I'm doing here is I am distributing this negative sign here to get x minus h over um, over x. Now remember, I had a 1 over h here in front. If you look at the few minutes past, or a couple of seconds past this video, you will see that there was an h there. Anyway, here we have now our expression. The x's cancel out. I like to mark it in different colors so that I can emphasize the fact that we're canceling. So here they cancel out. Now what we're left with is 1 over h times negative h x plus h. Alright, now remember, now you can see that we have an h in the numerator and h in the denominator. So these guys can cancel out to 1. And our expression, the expression that we're left with, as h approaches 0, is negative 1 over x plus h. Now in the limit as h approaches 0, this is simply equal to negative 1 over x squared, and this is our solution. Alright, that's our solution. Right, this is how we use the definition for this type of example. Now I just want to emphasize that the problem that I always see in students is the algebra. So hopefully the algebra here will serve as a review. All right. Let's do another example right now. Again, I'm just going to use the definition of the derivative. So find the derivative of f of x equals the square root of x. All right. So here's a solution. If you recall the previous example, the first step that I did was to write down the definition of the derivative. Nothing has really changed because I am going to just write my definition here. Alright, now what is f of x plus h is simply equal to the square root of x plus h, and f of x is equal to just the square root of x. Right. Now that we have what f of x plus h is and f of x are, we're going to again substitute this guy inside here, and we're going to substitute this guy inside here. Right? Let's go ahead and do that right now. I'm going to rewrite the definition of the derivative so you can see the workflow that I am doing. If you remember if you don't remember what f of x plus h and f of x are, you can always go back on this video. But here are my expressions right here. Now we have a very complicated expression here, and our objective is to we want to try to do as much algebra as possible so we can cancel an h here. So in this case, what I'm going to do is I'm going to multiply the numerator and the denominator by the square root of x plus h plus the square root of x plus h plus the square root of x. Okay. Let me emphasize here, this is a mathematical trick. It is perfectly legal, but because you can see that this expression right here is simply 1. Alright, so let's go ahead and multiply terms out. So if you multiply the numerator times the numerator and the denominator times the denominator using your FOIL expressions or any other way of that you've figured out how to multiply this, what we get is simply x plus h minus x. Alright, and in the denominator we get the square root of x plus h plus the square root of x. Alright, this cancels out, this cancels out, and then all I have to do now is take the limit as h approaches 0 of h square root of x plus h here plus the square root of x. Alright, now this h's cancel out. Oop. I want to really make sure that you see that the canceling is because of a division here, and what we are left with is now is the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. Alright, now in the limit as h approaches 0, this is simply like having 1 over the square root of x plus 1 over the square root of x. These are like terms, so like terms, and our expression then becomes 1 over twice the square root of x. Okay, and this is our solution. Just want to emphasize